Alright, so for the first 2 days with graphing, we focused on graphing from Vertex Form. We focus on Vertex Form first because in Vertex Form it is very easy to see how to graph a quadratic. Yesterday with the Delta Math, you really focused on plotting the points using a table. So today we're going to talk about how they found those tables. And we're going to be able to calculate the values in a table as well, using the idea of the perfect squares that we learned back at the beginning of the year. So if we're graphing a quadratic from standard form, what we want to first do is identify A, B, and C. So the standard form of a quadratic is ax squared plus bx plus c. So since the standard form of a quadratic goes in ABC order, the a value is on the x squared. So in this case, my a value is 1. The b value is always on the x. So in this case, it's 2. And the c value is always the constant, or 3. The reason we find and identify A, B, and C is to identify our axis of symmetry. The equation of the axis of symmetry in standard form is negative b divided by 2 times a. So the axis of symmetry in standard form is negative b divided by 2a. So in terms of this problem, it's negative 2 divided by 2 times 1, or negative 1. So what that means is my graph is going to be symmetric about the line x equals negative 1. So if I have a point to the right of that line, I'll have a point to the same distance away on the left. The y-coordinate of the vertex comes from plugging the x-coordinate in to the original equation. So we're going to find when x is negative 1. So negative squared is always a positive, so we have a 1. A 2 times a negative 1 is negative 2. So we have 1 minus 2, which is negative 1, plus 3, which is 2. So my vertex is at negative 1, positive 2. So my vertex is at negative 1, positive 2. My a value is positive, so that tells me that this is a minimum, and my graph opens up. The y-intercept in standard form is 0, c. So I'm also always guaranteed the point 0, 3. So what you'll notice is that point is up 1 and right 1 from the vertex, which means I have another point up 1 and left 1 from my vertex. And what we're going to do now is talk about how to make a table. So you have a decent amount of space between our directions and your graph, so you can use that area to create a table. For graphing a quadratic, your table is always x minus h. Ya plus k. So we're going to do x minus h, ya plus k. So that's why it's so important to find my h and my k. And again, my a value is the same for both standard and vertex form. A parent quadratic goes through 0, 0. So that's your x and y always. So the x and y are always the same. What we're going to do to find our new points is subtract h and multiply by a and add k. The parent function has 1 and 1. And then it has 2 and 4. Because our parent function is all of the perfect squares. So when x is 0, its perfect square match is 0, because 0 squared is 0. 1 squared is 1, 2 squared is 4. If your table continued 3 squared, it would be 3 and 9. And your table could continue on and on and on and on and on. So what we do to find our points on our graph is subtract h. So in this case, my h is -1. So subtracting -1 to get all of my x values, multiplying y times a, and adding k. And this works for standard or vertex form. So you can see 0 minus 1 is -1. 0 plus 2 is 2, so that's your vertex. That top point right here, the top point will always be your vertex. Okay? Then we have 1 minus 1, which is 0. 1 times 1 is 1. 1 plus 2 is 3. We can see there's my point 0, 3. 2 minus 1 is 1. So my point at 1 is going to be at a height of 4 times 1, which is 4, plus 2, which is 6. And remember, however many points it is to the right of the yellow line, it will also be to the left. And then we also have one last point. 3 minus 1 is 2. And then 9 times 1 plus 2 is 11. So that would be up here. And then you connect them to get your parabolic curve. Okay, number 2. Identify A and B so that we can convert from standard form to vertex form. So your A value is 2. Your B value is 10. And my C value is 7. Find your vertex H and K. So H is x equals, it's -b divided by 2a So it's negative 5/2. You have to then take that value and plug it in to the original equation. So go ahead, take a minute, use a calculator, figure out what that value would be. Put it away or I'll throw it away. If it's not math, it shouldn't be out. Okay? So go ahead and find out what that value would be. I'm going to need a calculator for the next problem as well. So I do want to show you guys actually something on your calculators also, because we haven't done a ton with them, and I know a lot of you have the newer graphing calculators. So what I want to do is actually show you, if I find my graphing calculator, a way to put fractions in on your calculator screens and to put in from one form to the other. So I'm actually going to put my calculator up for you for a second right now. What? All right. So, ladies and gentlemen, on that graphing calculator, if you didn't know the trick, if you turn on your calculator and you hit the alpha key right here, then that lets you type in letters, but if you hit second alpha, sorry, second y equals, I was trying to teach you the next part. Clearly, alpha, y equals, there we go. So just hitting alpha lets you type in numbers. If you hit alpha, let's do it again, y equals, you'll see this screen pops up. That's like the fraction button you used to have on those calculators you liked back in the day, like the TI 34s or whatever. If you hit the N over D, that stands for numerator over denominator. So you could actually type in a fraction on the graphing calculator. And what that does is if you type in using the fraction key on the graphing calculator, so like let's say I wanted to multiply that by another fraction. I should do something that won't simplify. My answer will actually return to me as a fraction. If you want your answer as a decimal, you go to the math key and you go down to option 2 and that's DEC for decimal, and it will take that answer and turn it back into a decimal. Did you guys know how to do that? Some of you yes, some of you no. And then if you want to take an answer, you go back up and like highlight it and they'll bring it back with you. So like if I wanted to reuse that, I just hit enter and it will come back down. Okay, so what did you get for your answer to that part of the problem then? What is my k-value of my vertex? What's the k-value? What'd you get? Yep. Perfect. So it's either negative 11 halves or negative 5.5. So my h value was negative 2.5. My k value is negative 11 halves or negative 5.5. So in order to take standard form and put it in vertex form, I'm going to use the A from my original. I'm going to find H. I'm going to find K. And then I'm going to plug into y equals A x minus H squared plus K. You can clean up the minus a minus if you want. The big thing is not forgetting the squared. All right? Take a minute, read through that example. This is a fairly accurate equation for this bridge that actually exists in West Virginia. I am sure many of you have driven over it without realizing. What? Yes. All right. So it says that we can model the arch of this bridge. So here's the arch. That arch can be modeled using the equation given to you above. How high above the river is the arch, as well as how long is the section of the bridge? So we want to know two things. We want to know how long is the arched section of the bridge, and how high is that arch. Now again, you're not finding the height to the water because the bridge arch wouldn't go all the way down there. So we're finding a few pieces of information. So this point here on that yellow archway would represent what value of a quadratic? That high point here, what's the maximum of a vertex called? It's an entire name of a quadratic equation. Hint 1, it tells you to find this in step 1. Thank you. have a really good wait period. The vertex. This little red dot is called the vertex. We need to find the vertex to answer these questions. We need to find the vertex to answer these questions. So, I told you you're going to need those calculators because these are some crazy long decimals. Go ahead now and find your vertex. So your vertex would be negative b divided by 2 times a. You're going to have to watch how you multiply. So again, if you multiply, you have to watch how you put your parentheses on the graphing calculator. So that's what I show in this example here, is if you are going to multiply that, you have to make sure when you put that in the graphing calculator that you have the bottom grouped together before you divide. So you could also put a set of parentheses here and here. But on your graphing calculator, you have to be careful. If you do 0.847 divided by 2 times, it will divide the 0.847 by 2 and then multiply by that decimal. So you either have to have parentheses or you need to simplify the denominator first. Does everybody understand what I mean? You either have to group your bottom or you have to simplify it first. We all got 850, we're good? So that 850 represents the h value. That is the x coordinate. So that 850 doesn't represent the height. That 850 actually represents the distance from here to the beginning. That's what this 850 represents. Okay, part 2, find the y coordinate. So you're going to take that 850 and you are going to plug it in for x back into the original equation. So this might look a little bit like physics if you guys are in physics, because this is kind of looking at like the path of a trajectory. That 850 would represent the distance from its starting point to halfway through its flight. This 360 would represent the max flight or height of an object in the air. And then that 850 times 2 would be when the object hits the ground again. So that 850 could kind of represent like your time if you're talking about a trajectory of an object. So again, if you're in physics, you should definitely, this should seem a little familiar. No, not at all. Projectile motion. It's projectile motion. I'll do an example with you on one that will hopefully. Well, it's a great question for your test.
Yeah, we celebrated our knowledge sufficiently.
I didn't do too good on the test.
Alright, so step 3, find the height of the arch. So this is what I was saying, that arch height is actually the height of the bridge arch plus the height the arch is above the water. So the arch is actually 516 feet above the water. Therefore, the highest peak of that bridge to the water is 876 feet. So the highest peak to the water is 876 feet. So an average, if you're like 6 feet tall, that would be 146 of you. So like 150, more than your whole entire graduating class standing on top of each other. Okay, and then the last part, how long is the bridge? How long is the bridge? So again, the length of the bridge, would be twice the x-coordinate of the vertex. How long is the section of the bridge? Well, that would be that 850 times 2. So you are on that bridge for 1,700 feet. It is not a very long bridge. It is just the largest arched steel bridge. Okay? So that summarizes our information. I want to use the bottom of that note page to give you the table for graphing one more time. So again, we are graphing these types of functions. So I want you at the bottom of that table just to kind of give yourself this x minus h, ya plus k. So the values that are never changing are the x 0, 1, 2 and the y 0, 1, 4. You are changing your a, h, and k. Do we need to make one more table, even from like your homework problems, just to understand this, or are you okay? Okay? So then you are doing 5-1 day 3, and again tomorrow morning you have to turn in day 1, day 2, and day 3 for 3 nights worth of credit. What? Yes, it is a lot if you did not do it. Yep. Nope. Nope. Properties of parabolas is for tomorrow. Yep. Just the day 3, 1 through 8. Again, make sure you follow the directions. I ask you for a lot of information. I ask you for y-intercept. I ask you for the equation of the axis of symmetry and the vertex. And then for graphing quadratics, you should always have 5 points. So you find 3 of them in your table, and then the other 2 come from the symmetry of that table.